In this video, I'm going to be going over lines in 3D. So let's just graph this real quick. What does this look like? What's a line in 3D? Well, we previously went over vectors in 3D, so it's basically the same concept. I'll just draw this arbitrary red line that should exist somewhere in a 3D space. And I'll draw another line just for the fun of it, right here. Both of these are lines in 3D. Now, in a 2D plane, how do we write lines? We usually have an x and a y coordinate, and then we have another, I call it x prime and a y prime coordinate. All right, and you can find the slope between these two. So m is just the change in y over the change in x, and then you can find your b value. This y-intercept, b is y-intercept, and you just end up with y is equal to mx plus b. So you can write a line like this, just in regular Cartesian form, rectangular coordinates. But can we do that with a 3D space? Does that make sense? Well, not quite. So I'm going to assume you guys are familiar with parametric form. But just a quick overview, it's basically just writing something as a function of time. So I can say the x component is x of t, and I could say this is, say, 3t plus 1, and y of t would be maybe 7t over 2. And with this, I can come up with a y equals mx plus b equation. But in 3D, I can only write it as a function of t, meaning I cannot write it in Cartesian form. It can only be written in parametric form, 3D lines. All right, so let's go over a practice problem to sort of introduce us to this concept. So find the line that passes through the points 172 and 322. So similar to finding the equation of a line in 2D, you just need 2 points to find the equation of a line in 3D. So we can graph this real quick. Z, x, y. And I'll put these vectors down. I'll just treat them as vectors. I have 1, 7, 2, something like this. And I have 3, 2, 2. So 3, 2, 2. And I'll just put my 2 points right here. And I want to find this line, the line that passes through these 2 points. So I'll just call this first vector, you could say, A, this first point A. The second point is B. Alright, so this is B and this is A. So I'll just map this into a more, I guess, 2D perspective. Right, so we have our vector A, we have our vector B, and then we have our line here. I'll just label these. So if A plus something is B, what is the something? Well, it's just B minus A. Well, that makes sense, right? A plus B minus A is just B, meaning this yellow line right here is simply B minus A. So I can represent this vector. I'll do this in blue. I can represent this vector as just B minus A. So here I have A to get myself to this spot. So here's A plus B minus A. But that just gives us this spot. That just gives us this vector right here. We want this entire line. And this is where this whole idea of making it parametric comes in. So I need some, I guess, variable, some independent variable. You can call it t. Right? We can write it in terms of time. So this basically dilates b minus a by any factor, and this lets us cover this entire line, this scalar t. Because without this t, we'd just get this part. So multiplying this whole thing by t, this b minus a term by t, we get the entire line. So this, you could just say, is minus f of t. Okay, so now we'll solve this problem. We have our formula right here. This is how we find the equation of a line, a plus t times b minus a. So let's just plug this in then. What's a? A is 172, so I'll put that right here so I can refer back to it. And b is 322. Alright, so now I can plug this in. I have f of t is equal to a, 172, plus t times b minus a, 322, minus 172, which is just f of t is equal to 172 plus t times 2, negative 5, and 0. So this is the equation of our line. All right, this new question is asking for the line that passes through 3, negative 1, 4, and 8, 2, 1. So I guess we could graph this again, making it a bit more clear. We have 3, negative 1. Actually, I should probably extend these axes. We have 3, negative 1, and 4. So I could say maybe here. And then 8, 2, 1. These drawings are pretty bad, but it's hard for me to draw in 3D. So basically this, just this line. So I can map this into a more 2D looking thing. First, I'll just call this A. I'll call this B. So we have this vector A, this vector B, A, B. We have this, we could treat this as a vector for now, B minus A. We want this B minus A. So to get from the origin to this place right here, this point, we need to add A. We have A plus this vector B minus A. So t times B minus A should give us this line. And then I can write this as a function of t. All right, so our 2 points are 3, negative 1, 4, and 8, 2, 1. So f of t would just be 3, negative 1, 4, plus t times b minus a is just 8, 2, 1, minus 3, negative 1, 4, which can be rewritten as 3, negative 1, 4, plus t times 5, 3, negative 3. And this should be our new line. All right, so this question is asking for something different. Find the intersection of the lines made up by the points 3, 1, 2, 7, 3, 1. So this is one line, and 4, 1, 2, 2, 1, 1. This is another line. So hopefully we have this, I guess, equation of a line format memorized, or understood at least. So we have 3, 1, 2. I'll just call these A and B. So we have 3, 1, 2 plus t times 7, 3, 1 minus 3, 1, 2. And this is just 3, 1, 2 plus t times 4, 2, negative 1. In our second line, I'll write this as a function of s, still a function of time. And this would be A, this would B. I have 4, 1, 2 plus t times b minus a, which gives us 2 minus 4, 1 minus 1, and 1 minus 2, which can be rewritten as 4, 1, 2 plus t times negative 2, 0, negative 1. So here are our two lines. Now remember that the problem is asking for the intersection between these two lines. So a good thing about parametric form is that we can always turn these into points. If you remember from my last video, this first, row you could call it, is the x component, the second row is the y component, third row is the z component. So just adding these two vectors together, we have 3 plus 4t as the x component. Y component is 1 plus 2t, and z component is 2 minus t. And we can do the same thing with this other line. We have 4 minus 2s, 1 plus 0s, and 2 minus s. So just from looking at this last equation, I know that the values of s and t are the same, meaning I just need to solve for one of them. Well, good thing I have two equations and two variables. All right, so the first one, we have 3 plus 4t is equal to 4 minus 2s, and 1 plus 2t is equal to 1. That's it. So I can look at this second equation. This one's looking pretty good. And this can turn into 2t is equal to 0. So t is equal to 0. This means that s is also equal to 0. Right, I have s is also equal to 0. And just checking this, if t is 0, I have Alright, so I know that t is equal to 0, and that means s is equal to 0. Well, just to check my work, I'll also do it with systems of equations instead of just focusing on one equation. And just to make sure, I have this, and then I can multiply this bottom equation by 2. And then I can subtract. 1 plus 0 is equal to 2 minus 2s. So I have negative 1 is equal to negative 2s. So s is equal to 1/2. Wait a minute. If s is 1/2 and s is 0, well, that doesn't really work, right? This whole thing is just very wrong. This means only one thing. This means that these two lines do not intersect. Meaning I've been messing with you.